The topic for today is sequences and strings. A bag or multiset is a collection of objects whose members need not be distinct, unlike a set, whose members are distinct. Bag is an extension of a set, whereby the repetition of elements is taken into consideration. The number of repetitions of each member is the multiplicity of that member. So, if B is a set, then set of A, B is equal to set of A, B. But, if B is a bag, then bag of A, B is not equal to bag of A, B. For the bag A, B, the multiplicity of A is 3, and the multiplicity of B is 1. A sequence is an ordered list of elements, usually defined according to a formula. If S is a sequence Sn, such that n equals to 1, 2, 3, and so on, then S1 denotes the first element, S2 the second element, and so on, until Sn, the n element. N is called the indexing set of the sequence. Usually the indexing set is the set of natural numbers, n. Please be aware that the use of the set notation for sequences does not have the same meaning as they do when they are used in set theory. There are some operations that can be done on sequences. If set S contains element A, B, C, D, E and F is a sequence, then head of S is A. Tail of S is B, C, D, E and F. First of S is A, B, C, D and E. And last of S is F. If S1 equal to set A, B and C, and S2 equal to D and E, then concatenation of S1 and S2 is denoted as S1, S2 equal to the set A, B, C, D and E. A sequence of integers is an ordered list of numbers, defined by listing its elements or by using a formula. Sn equals to a function fn for n equals to 1, 2, 3 and so on. Fn is a function involving n. Let S equals to Sn be the sequence defined by Sn equals to 1 over n, for n equal to 1, 2, 3 and so on. Hence, a few elements of the sequence are 1, 1 over 2, 1 over 3, 1 over 4, and so on. Let S equals to Sn be the sequence defined by Sn equals to S, n minus 1 plus S, n minus 2. For n equal to 1, 2, 3 and so on. S1 equals to 1, and S2 equals to 1. Thus, the first few elements of the S are 1, 1, 2, 3, 8, and so on. A sequence, S equals to Sn, is said to be increasing if Sn less than Sn plus 1, for every n equal to 1, 2, 3, and so on. Sn equal to 2 to the power of n, minus 1, for n equal to 1, 2, 3, and so on. Thus, the first few elements of S are 1, 3, 5, 7, 9, and so on. The sequence S equals to Sn is said to be non-decreasing if Sn less than or equal to Sn plus 1. The sequence of non-decreasing is 1, 2, 3, 3, 4, 5, 5. A sequence S equal Sn is said to be decreasing if Sn more than Sn plus 1 for every n equal to 1, 2, 3, and so on. Sn equal to 4 minus 2, to the power of n, for n equal to 1, 2, 3, and so on. Thus, the first few elements of S are 2, 0, minus 2, minus 4, minus 6 and so on. A sequence of S equals to Sn is said to be non-increasing if Sn more than or equal to Sn plus 1. The sequence of non-increasing is 100, 90, 90, 74, 74, 74, 30. A subsequence of a sequence S is a sequence T that consists of certain elements of S retained in the original order they had in S. If S equals set to A, B, C, D, and E, then T equals to A, B, and C is a subsequence of S. Let S equals to Sn equals to n, such that n equals to 1, 2, 3, and so on. This gives us the sequence 1, 2, 3, 4, 5, and so on. Let T equals to Tn equals to 2n, such that n equals to 1, 2, 3, and so on. This gives us the sequence 2, 4, 6, 8, 10 and so on. Observe that T fulfills the definition of a subsequence. Hence, it is a subsequence of S. We can add up the elements in a sequence to get its sum. Here, we can use the sigma notation. If An is a sequence, then the sum of Ak, from k equals to 1 to m, is equals to A1, plus A2, plus A3, plus, up to Am. Besides adding up the element, we can also form the product of elements. In this case, we use the pi notation. If An is a sequence, then the product of A, k, from k equals to 1 to m, is equals to A1 times A2 times A3 times, up to Am. Sometimes, in computer science, we deal with finite sequences, which are called strings. Let X be a non-empty set. Thus, a string over X is a finite sequence of elements from X. If X equals to the set with elements A, B, and C, then alpha equals to BBACCC is a string over X. B, B, A, C, 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 is equals to B square, A, C cube. The length of a string alpha is the number of elements of alpha, and is denoted by the symbol as shown. If alpha equals to b square, a, c cube, then, the length of alpha is 6. The null string is the string with no elements, denoted by the Greek letter lambda. It has length 0. X star is the set containing all strings over X, including lambda. X plus is the set of all non-null strings. Concatenation of two strings alpha and beta is the operation on strings consisting of writing alpha, followed by beta, to produce a new string alpha beta. For example, if alpha equals to b, b, a, c, 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 and beta equals to c, a, b, a, then, the concatenation of the string alpha beta is equal to b square, ac to the power of 4, a square, ba. The length of string alpha beta is 11.